Yeah. So now the call is being recorded. Okay. So Aditya, do you have any problems from the previous class we did? We talked about measurements and distances. Hello, am I audible? So do you have any doubt?
No, sir.
Okay, great. So children, today we are starting up with a new unit, which is lights, shadows, and reflections. Okay. So like it's a very common thing. We all have heard of a term known as shadow, right? We all have like felt our shadows. We have seen shadows nearby. So what are those? So like firstly, before moving to shadow, let's talk about light. As the chapter said, light, shadows, and reflection. Okay. So what is light? Do you have a light nearby you? Do you have a tube light in room?
Sir, and some kids thought with a friend, their friend, shadow
Huh?
friend.
Sorry.
No, sir. If some kids, if a kid, small kid will see the shadow, and it will he will think that it is a black friend.
Yeah. You are right. We'll discuss shadows in the coming
Black friend.
slide. Yeah. You are right. Very right. Yes, that can be a general observation of a small child. Yes, you are right. Okay. So as I was just saying, you might have seen a tube light in your room. It can be an LED light. You might have seen LED bulbs. These are very common these days. What do LED bulbs do? They emit light, right? White color light or any colored light you might have seen. Light is coming out of the bulbs, right? So that is basically the light. Now, light is a form of energy. Okay. Well, we are not entering into defining light at the moment, but yeah, light is a thing because of which we can see the world. If light was not there, we could not have seen the world. Like it's very obvious. For example, if I enter into a dark room, I cannot see objects nearby. Why cannot I see objects nearby? The reason is if there is no light in the room, I cannot see objects. Hence, if the room is dark, I cannot see objects, right? You cannot see objects during night in your room when the light is turned off, right? So that is the reason. So light is something that helps us to see objects around us. If there is no light, we cannot see the objects around us. All right. Like sun is the biggest source of, okay, is a small error. Yeah, sun is the biggest source of light, right? And like it is never exhaustive. It will never exhaust. Sun is a continuous source of light. It is an infinite source of light. Like earth gets light through sun majorly. And okay, so we can divide substances into two categories. First one are luminous, and others are non-luminous. Okay, so what are luminous substances, children? Substances that emit light. For example, sun emits light, right? Yes or no?
Yes, sir.
Yes, very good. Sun emits light. Similarly, a bulb emits light. It is luminous. A tube light emits light. A candle emits light, right? A firefly emits light, right? We call them as jugnu in Hindi. They emit light. So these all are luminous substances, luminous objects. All right. Now, these luminous sources, you might have observed, these can be either man-made or natural, right? If it is sun, it is not man-made. It is natural luminous, naturally luminous, natural. Whereas if I talk of a candle, candle is man-made, right? Is it getting clear? I'll just switch to Jamboard and I'll explain in more detail.
No, sir, it is correct.
I hope you are getting it, but still, like, we have a new friend today, and like It's her first day, so we'll go for a better understanding of concepts so that she can fit easily into the classes. Okay. So, yeah, as I said, there can be two types of objects, luminous and non-luminous. Okay. Now, these luminous objects can be either man-made or natural. Natural means that are not created by humans, very obviously, and man-made means created by humans, very obviously, or created by man, right? So, like man-made objects, luminous objects can be like a candle, it can be a lamp. If I talk about the natural resources, it can be sun, it can be a firefly. And non-luminous objects, very like we have n number of examples for non-luminous which do not emit light. For example, would you people like to give some examples? You can also write in the chat box, or I would like appreciate if you turn on the mic. That's always great. So, yes, any examples of non-luminous objects? Okay, I can give you a ball is non-luminous, a bat is non-luminous, a football is non-luminous, a book is non-luminous.
The mouse.
Sorry,
Mouse.
the word was not clear.
Sir, mouse.
Mouse, yeah, very good. Mouse. Or like human beings, we are also non-luminous, right? We do not emit light. That's very obvious. Okay, now I have a question for both of you.
Sir, moon.
Moon, yeah, I was just going to say moon. Now, moon is luminous or non-luminous?
The non-luminous.
Okay, and the other child, what's your opinion?
Sir, I think she is not there.
No, she is there. Yes, yes, please.
For non-luminous.
Okay, so you say it as non-luminous, and Aditya also say it as non-luminous, and you both are right. It is non-luminous. Now I'll explain you why. It is non-luminous, but
Sir, I can tell why it is non-luminous.
hi, you can say it. It's great, but you know I have to explain it once. Like okay, you can say it for the other questions that I'm just going to ask. All right. So shall I go with it? I'll explain it. Then I will ask you more questions on it. Okay. All right.
Yes, sir.
Yeah. Okay. So basically, children, I can just ask you. There is a moon. Okay. When I see it in night, it glows with a yellow color light. Yellow, or sometimes it has red. Sometimes it is white. It has light. Almost every time we see the moon, except on the new moon day, like moon appears to me like a white object, like a like a red object, like a yellow object, depending upon the temperatures, and there are various other factors. But moon glows. But you people are saying it is non-luminous. Yes, but it is non-luminous because moon does not produces its own light. Moon does not give its own light. All right, it does not give its own light. It's the light that is coming from sun. The light that is coming from sun and gets reflected on the moon. It reflects on the moon and comes to our eyes. If I just draw eye here, assume it to be the eye. My drawing is not so good. So this light reflects on moon and fall into our eyes, and we can see the moon. Okay, so that is the reason moon is considered as a non-luminous object. Not just moon, everything is non-luminous. How? Now I'll explain one more concept. It's very important. Now, how do we see objects? How do we see objects? It's again very important. Now what happens, children, if there is a light source, this can be anything. It can be sun, it can be light in the room, tube light or an LED light, whatever is being used in your room. Now this light, assume this to be a water bottle. Like I have a water bottle in front of me with me. Now this bottle is kept in front of me and I can see this bottle. But how? Okay, like I am sitting here and my eye is here. Now what will happen, children? The ray of light from this source will come onto this bottle, and after it falls on this bottle, this light will bounce back and it will come into my eye. Okay, now you might be thinking it can go anywhere else. Yes, it can go anywhere else. It will go in all directions, and in those all directions there can be any other eye. Like if Aditya is sitting here, right? So he'll see the bottle from this direction. I'll see the water from this direction. There is a new friend with us today. If she sits here, she can see it from here, right? Light will fall in every direction. And like I am sitting here, so light will fall in my direction and I will be able to see the bottle. So how do we see objects? Basically, light falls onto the object, it bounces, it reflects. This term is known as reflect. We'll study reflection in the coming slides, but now the word is being used, so I'm using it. This light will reflect from that bottle and enter into my eyes, and I will be able to see the bottle, right? So this is the phenomena of like how we see objects around us. All right, so is this clear, children? Yes or no?
Yes, sir.
Yeah, I hope this is clear. Now I'll move to the slides that I have. Yeah, so we just now discussed, children, like what are luminous objects, what are non-luminous objects, their examples, they are man-made or natural. Then we went to how we see objects around us. All right, so now I'll move to the next slide. Now, yeah, this is very easy slide. Okay, so now I would request you, both of you, to participate. Okay, now what is this slide basically saying about? That, we can categorize substances into three categories mainly. First is transparent, next is translucent, and the third one is opaque. Have you heard of these terms? We have used these terms in a previous chapter in our chemistry class as well. Do you remember? What are transparent substances?
Sir, the substances that help the light completely pass through them, and we can see it is
Through it.
totally through it without any effort. That is for transparent. And
Yeah. We'll ask translucent and opaque to our friend. Okay. So yes, very good, Aditya. You said it rightly. What are transparent objects? Like as you said, through which we can see without any efforts. Very good. You used a very good term, without any efforts. And then we had with us, you said that light can easily pass through it. Yes. Yes, very good. Now, I would like to ask my new friend today that could you tell us what are opaque objects? Is she here? Yes, are you here? Yeah, okay, so I guess she is not available. Okay, so Aditya, am I audible?
yes, sir.
Yeah, so now you may go on with what are opaque objects and what are translucent. Okay, go with opaque, and if our friend comes by the time, we'll ask her what are translucent objects. All right?
Yes, sir.
Yeah, so what are opaque objects?
Sir, opaque objects are objects that do not allow any light to pass through them, and we cannot see through their. We cannot.
Yeah, you are right. This is opaque.
Yes, sir.
This is transparent.
So translucent is the object that some percent of lights can be passed through it, and
Yeah, that's enough. You are right. Some percentage of light can pass, and we cannot see the objects clearly. We can see them, but not very clearly. Very good. You said it right.
we can only see their outlines clearly.
Yeah, you are right. Yes, you are right. So, do you agree, the other child?
Yes, sir.
The other child with us today, do you agree?
Yes, sir.
No, I'm asking her if she can. Was it clear to you? Yeah, great. Okay.
No,
Now,
sir. Some sounds have come. He's not there.
no, she is here. She is answering. Yes. Okay, great. So let's move ahead.
I think her mic is not means off. Her mic is not not capturing his voice.
No issues. Okay, you can listen to us. And if you have any queries or if you want to ask anything, you can every time use the chat box, even to reply. Okay, like yes or no can be answered via chat box. Also, you can turn on your mic. I have no issues with it. Okay. Now, like in the beginning, we were discussing about a term called shadows. Now, I'll explain you what are shadows. For example, children, when there is like for example, this is my sun. Okay, so this is my sun, and from this sun, light is emitting out. It can be sun or any light source. All right. Now, this light is emitting out. Listen carefully. Okay. Now, this light is coming like this. Now, if I place a ball here.
I can tell what is shadow.
Huh?
I can tell what is shadow.
Yeah, I'll explain it. I'm just explaining it, child. I'm just explaining it. Just a moment. Yeah, okay. So, for example, if I keep a ball in front of these light rays that are coming from sun or any light source, so few light rays will fall on this ball and few will move along straight line, right? They will not fall on the ball. Now, if I place a screen here, a screen is like just a piece of paper or a cardboard, any sheet, then you will observe that I'll just change my color. Yeah, that these light rays fall here, but here a gap gets formed, a dark gap. Now, if no light will fall here, nothing will be visible in this part, and this will be a black spot. And this black spot is known as shadow. Okay, so the dark patch formed by a body on the screen is its shadow. Like if there is a body kept here, any body, it can be even a human being, right? Human beings have shadows. Like if this is the sun here, so light is falling on this person, which does not fall will move into the straight direction. But if this person obstructs the path of light, a shadow will be formed on the screen. Like for example, if sun is over my head, now what is the screen? Earth is the screen. So my shadow will be formed on earth. Now if I just stand in front of a wall and another person throws light on me through a torch, okay, so my shadow will be formed on the wall, right? Is this clear? Aditya, is that clear?
Yes, sir.
And the new child, our new friend?
Yes, sir.
Yeah, very good. Was this clear? Now, did you get it? What are shadows? Like shadows are nothing but a dark patch a dark, a spot that is formed when a body obstructs the path of light. Now, for example, if there is no light, then there will be no shadows. Aditya, do you observe any shadows in a dark room?
No, sir.
Yeah, very obviously, because,
Because it is only dark.
huh?
Sir, because it is dark and shadow is also because it is black and shadow is also black. That's why we cannot see in a
Um,
room.
but you said the room is black. Now, if I just paint the walls as black, so my shadow will not be visible. You mean that, right?
Mm.
But no, actually, in a dark room, if the room is dark, there is no light, right? And if there is no light, how will the shadow be formed? For example, this room is fully black. If the room is black, this means that there is no light. And if there is no light, because if light was there, the room would not have been dark, right? If there was light, the room would not be dark. No, I'll explain it again. Okay, so am I audible now? Because like in online classes, it's very risky if I just keep on speaking and my audio doesn't reach there. Hello, children.
Yes, sir.
I was just saying, if there is no light in the room, no light in the room, so no shadow will be formed. Now, when there is no light in the room is known as dark room.
Yes, sir.
Yeah, that's the thing that I just wanted to say. There is no shadow formed if there is no light. Okay, so now, like we have reached so far, now like I'll move again to my Jamboard and I will revise whatever we have studied, and then I will move ahead. Okay. Yeah. Visible? Yeah, visible. So, like we have just now discussed the concept of shadows. Okay, for example, like I just said, if there is any source of light, for example, if there is a bulb, it will emit light in all direction. This is source of light. Now, if I place a ball here, okay, let's not place a ball here. Let's place something else. What should we place? Okay, let's place a
Sir,
textbook.
plank. Sir, plank.
A plank.
Yes, sir. Tree plank. Plank.
That would not be interesting. Kind of, let's place something interesting that we remember all the time, that while we were studying shadows we use this. So let's place a
Car.
car. Okay, as you say, let's place a car, but as always I say, my drawing is not so good.
Sir, dress a toy car. It's not a toy car.
Okay, yeah, toy car. Every car like I'll draw would look like a toy car. So okay, assume this to be a car. Okay. Yeah, well, I draw well. Um, yeah, it looks fine. There should be an antenna. But what's the forward direction? We don't know. Okay, so like let's just drop this antenna. Okay, so now children, okay, assume there is this yellow light coming from the bulb. So light that will come from this part will be struck by the car. It will not be allowed to move in the forward direction. And if there is a screen with us, okay, let's try this option for a screen. Okay, I don't know whether it will work. No, it will not work. So let's just drop it. Okay. Okay. Okay, so let's just draw it directly because it's not working fine. Yeah. Assume there is a screen here. Here is the screen. Now, children, this yellow light would come and fall on the screen. Am I right? But these ray of lights will not fall on this part, and a shadow will be formed here. Okay. Now, a very important question to both of you. What will be the color of this shadow? Hello? Yes, go on.
Is that black?
Yes, very good. I was just thinking, like, I was just waiting if you say it as yellow, but no, you said it rightly. The color of shadow is always black. Shadows are always black.
Sir, I was telling black, but I seen that my mic is off.
Okay, no issues. But I appreciate you both, like, interpreted it correctly. Shadows are always black in color. Have you ever seen colorful shadows? No, they do not exist. Like, I was just preparing to teach today for, like, I was just preparing the lecture. So I just went on to Google to, get some good images of shadows. So there was an image where, shadow was colorful. So at that moment, I thought, okay, I'll discuss this in today's class, where I'll ask them whether shadows are colored or not. So you both interpreted it correctly, that shadows cannot be colored. Shadows are always black. Are always black. Very good. So children, we can say whenever there is no light, it is dark. It is dark, right? Like, shadow is a spot where light cannot reach. And if light cannot reach, then that place is black, and black is usually termed as dark, right? So is it clear? I hope it is clear. Okay, so now let's get back to the slides. Okay, so the slides are here. Yeah, so we just now discussed the concepts of shadows. Shadows are always black, and okay, we just discussed this only. And they are formed when light rays cannot. Okay. Will a glass slab form a shadow? What do you say? Will a glass slab form a shadow? Hello children, am I audible? Okay, I guess there is a network issue now. Let me just check it.
Yes, sir.
Am I audible?
Yes, sir.
Yeah, I was just asking, will a glass slab, will form a shadow or not?
Sir, no, sir, because it is transparent.
Yes, very good, because it will not stop the light. It will allow the light to pass through it.
Yes, sir.
Yes, so no shadow is formed. Okay? Yeah, very good. So let's move ahead.
Yes, sir.
Yeah, okay. Yeah, okay. These games you might have played someday. Have you ever tried, children? Like, we can just twist our hands in some shapes and all, and we can make different objects. Like this way, I can make a bird. Right? Can you see it? I'm making it on the camera. Like we can make a bird like this. This person is trying. Okay, see bird, as I said. This is a bird here. Now, this is kind of a horse something, or I'm not sure which animal is this. Like this looks like a dog, right? We can make ducks. You can make any shape. Like, what is this happening? Like I am keeping a torch kind of substance here. Now from torch, light is coming out. Now the light is getting stuck by my hand, and the shadow of hand is falling on the screen. This is a screen. This can be anything. Screen can be anything. Screen can be a wall. It can be a piece of cloth. It can be anything, children. So like I'll just erase it and draw it again because I guess it's not very clear. Like, see, do you children agree that from this torch, light rays will come out? Hello, please
Yes,
reply.
sir.
Yeah, very good. So now the light rays will fall in the will go in a straight direction and fall on the screen, except these rays that are coming onto the hand and they are getting stuck or they are getting stopped by the hand, and a shadow is getting formed of hand. And now I have kept my hand in such a way that these shadows are being formed. Do you agree? Have you ever tried this?
Yes, sir.
Yeah, okay. If you have not tried, today I am giving you it as an assignment. Take it as an assignment, take it as an activity that you will do at your homes today. Like you can use your mobile phone's torch and just, switch off the light of the room, ask your sibling or ask your parent to parent, be it your mom or dad, just anyone present nearby you, just ask to hold the torch and try making various shapes. So that's a small assignment you can try today. Like it will help you in better interpreting what are shadows, and you will get a better clarity. Okay, like it's a small play. You can, you can just challenge your friends. Okay, make a dog using your hands, right? Okay, so will you try it? Okay, I'll ask in the next session, did you try it or not?
Yep.
Okay, great. So like now, very important. Now, children, we are moving to a very important topic of the day. Now, I request your maximum attention.
Sir, inverted camera. Inverted camera.
Yeah, very good. This is a pinhole camera or invertible or inverted camera, as you said. Very good. Now, how it works, I hope you know because you have completed your class 6. Now, I will explain once and then we will
No,
ask.
sir. I am in class 6.
Oh, yeah, means you will move to class 7, no?
No, sir. I am in class 6. I will. Means I have completed my class 6. I am in class 5. Means I have come from
Okay,
class
okay. So
5.
you have come up from class 5 and now you will move to class 6. Okay, great. Okay. Okay, but still I'll explain you what is this. Okay, pinhole camera. Now listen to me carefully. Okay, now I am
I
making
am
a
not in
camera at
7.
my home. Huh?
I am not in 7 or
Okay, no
6.
issues, but I am teaching class 6, right?
Yes, sir. Because
Yeah,
I will move to class 6 in future
yeah.
chapter.
Okay, great. Okay, now listen to me carefully. Now, what is a pinhole camera? Now, it's a camera. Okay, what is a camera? You might have seen in your mobiles, you have a camera here. Now, what does what does camera do? Camera captures the images around us, right? Objects around us in the form of images. Now, in the previous days, children, in the olden days when we didn't have any digital cameras, we started our journey with these pinhole cameras. These form the basis of the formation of cameras. You will study more forms of camera in class 8. A shutter camera. Okay, so that's not now. Let's study today, which is a pinhole camera. Now, what it is? It is a, I hope your mic is, I guess your mic is on. Okay, yeah. So, like pinhole camera is a camera that is formed using two cardboard boxes, and like this is the bigger box, this is a smaller box, this is a smaller box, this is a bigger box, and in the bigger box I will make a small pinhole using a thumb pin, a very small hole, and I will take a smaller box which can easily slide into this big box, this big box, and in this smaller box I'll make a window, or you can say a rectangular patch. It can be a 5 to 6 centimeter side. You will just cut it out and place a butter paper here. I guess someone wants to say something because the hand is being raised.
Sir,
Anyone?
and at the last we will use the oil paper.
What?
At the last we will use the oil paper.
Yeah. You are right. Like what happens?
Oil,
Oil. You are saying OIL, right?
oil paper.
The word is not clear. Type it in the chat box.
Sir, oil paper.
OIL.
Oil paper.
OIL, right? OIL paper.
Yes, sir.
Yeah. You are right. They like these are same things, right? So we'll place this paper here near the window or that we have cut out, and now children we'll do that. Like we'll slide this smaller box into this bigger box. We'll slide it inside like this, and what's going to happen, we will take a big black cloth, and using that black cloth we'll cover ourselves and this entire pinhole camera except the pin that we have made it in the front through which the light will enter. We will cover the rest part and we will look through that window and out of that pinhole. Okay, so what am I doing? I have taken a small box, I am looking through it, there is a small window in front of me, and out of that window, the window is covered with the butter paper or any, as you said, oil paper, and out after that butter paper in the series, I have a pin that I have made through the pinhole, the pin, like I have made the pinhole using a pin. Now I will slide my smaller box inside and I will look at the different objects, and I can, like make the images of that objects on this paper, and I can see that, right? Like I can see objects nearby my knee using this pinhole, and they can be, like an image can be made on this butter paper. For example, here is a any kind of, a tree is here. Okay, here is a tree. Now light from sun will fall onto the tree, and after falling out into the tree, it will come through this pinhole inside, and there will be not just a single ray, there will be many rays. And as you said, this is an inverted camera, invertible camera. An inverted image of the tree will be formed here. Like if tree is like this, the tree will be inverted like this. An image will be formed in front of me. Now, children, this setup is used to, to get an image of sun. To get an image of sun. Like we cannot see sun directly. We cannot see sun directly because it will damage our eyes. So we use a setup like this to capture the image of the sun on a screen, and on that screen we can study the structure of sun and various other changes such as eclipse. Do you know solar eclipse and lunar eclipse?
Okay.
Have you heard of the term eclipse?
Yes, sir.
Yeah. We cannot see those eclipse directly. Okay, so am I not audible? Because you were not audible to me. Okay, so I'll continue. We should never look at the sun directly, children, because it is hazardous. It is unsafe to look at sun directly because our eyes are very sensitive. Very sensitive.
You have to use the sunglass.
Okay, so yes, you are right. We should use a sunglass. Hello? Yeah, very good. We should use a sunglass. Why? Because our eyes are very sensitive and they will just get damaged because sun rays are very intense. And if they fall directly, you're actually, I guess it's a network issue at your end, Aditya. You are not audible to me. Okay, so Miss Negi, do you have any question? No, you are not audible. You can try joining again.
Okay, sir.
Okay, so by the time he joins, I'll repeat the concept what I was saying. I was just saying that we should never see sun directly through our naked eyes. We should have a covering or
Yes, sir.
sun. Yeah, you are audible
I,
now. Yes.
sir, I'm telling that because of ultraviolet rays.
Because of, yeah, very good. Because of ultraviolet rays from the sun, or UV rays we call them as. Yes, the rays coming from sun are a mixture of various rays such as UV rays, the infrared rays. These are not safe for our eyes. Hence it is preferred to have a medium, like like of a sunglass, that also is covered with wax, so that this does not damage your eyes. This is very, because eyes are highly sensitive. The retina inside it is very sensitive. Okay, now next thing. Okay, here is it's a typo, just ignore this I. Okay, light travels in a straight line. Do you agree? Yes. Because if I just look through a telescope, or kind of a tube-like structure onto a object which is present here, like a candle, it can be anything. So children, what will happen? I can see the candle. Why? Because the light that will emit from the candle will be coming in the straight line and will enter. Okay, I'm unable to draw it clearly. Just a moment. Yeah. So this, okay, yeah, so this light will be coming from here like this in a straight line. Okay, just assume it to be a straight line. Okay, wait, I'll change the screen. Now we have many other tools with us, so we can draw the straight line. Yeah. Okay, yeah, like I was saying, that assume here is a candle in front of us. Okay, now I have a long tube through which I am looking at the candle. Okay, here is my eye.
That the candle should be means the tube should be straight. Otherwise,
Yes,
it should be bended. We can't see the candle.
yes, you are right. Because, okay, no, I don't have it here. It is not of, it does not have very good functions. Okay, let's just delete it. Okay, how should I draw a straight line here? Okay, anyways, I'll draw
Sir,
it.
sir, I have an idea.
Yeah, yeah, go on.
Sir, the T1
T1, huh?
T.
T,
Sir, after sir, before the ray one, the last option, the second last option. Second, sir, you can click it once more.
okay,
I
this
have
one.
yes, sir. You
No,
can use the rectangle and stretch it, and it will be in a straight line.
okay,
Uh,
like we can try it afterwards, because we are falling short of time now. So yeah, so like what happens, children, the ray of light, okay, I'll just bend myself, like these ray of lights travel in a straight line. Now for an instance, this tube was not like this. Assume this tube was something kind of like this, something kind of like this, and I was looking from here. I assume this to be my eye, which is not at all beautiful at all. So sorry for that. Okay, I'll draw it again. It is not looking like an eye. So I hope you don't mind my, just pardon me for my bad drawing skills. Okay, now listen very carefully. Now what will happen? This light will travel in straight line like this, like this, like this, like this, but it will not bend like this. So I cannot see the candle. Right? If I am looking here and a candle is glowing behind me, I cannot see candle. Okay, spelling is wrong. CNDLE.
we
Okay,
can,
so
sir, we cannot see the candle, but some sort of light will come from there.
Yeah, but that is through different phenomena which I cannot teach today. That is diffraction of light. Diffraction, which is not in syllabus today, but yeah, when you will move to your higher classes, you will study those phenomena in detail. But by the time, we can just keep in our minds like, okay, but candle will not be visible, right? Do you agree? Candle will not be visible. Some light may come, but candle will
Yes,
not be visible. Agreed? Yeah. So let's move to the slides again. Okay.
sir, because if the cardboard will be shiny, the
Yes.
cardboard will be shiny, then the light will touch on it. The light will crash on it and come to our eye.
Yes, you are right. And that is known as the reflection.
Yes, sir, because of reflection.
Yes, very good. You know what will happen if this tube is shiny from inside? This light coming from here will reflect here, will enter like this, then like this, then like this, then like this, then like this, like this, like this, like this, like this, and will reach my eye. Did you want to say this?
Yes, sir.
Yes, very good, Aditya. You said it rightly. This is true. And this concept, this phenomena is widely used these days. This is known as optical fiber communication. Well, this is again out of syllabus, but like when I was doing my engineering, this was a subject. If complete subject, a complete course which was taught to us in a semester, optical fiber communication. Now you can just imagine how detailed things are inside this. But it's very great, like if you children are in class 6 and you are able to understand this concept at class 6 itself. So that's great. I appreciate your intellect, that you participated in this concept and you told it on your own. So that's great. Very good. So like this is very prevalent these days, optical fiber communication. Like internet that is being transmitted, coming to our homes using broadbands, they are moving to optical fiber cables. Those are very, like the signals travel through these cables, and that is just reflecting onto the opposite surface, then it moves back to the other surface, and that is known as an optical fiber communication. Okay, let's leave it aside, but I appreciate you said it. Very good. Okay, so let's now talk about reflection. Now, what is reflection? You children might know it. Reflection is nothing but the bouncing back of the light when it falls on a shiny surface. This shiny surface will reflect the light. It can be in any direction, but majorly, if I say, you will study this in class 7 in detail, I hope. These laws of reflection, when light falls on a mirror, it will reflect back in this direction, and this angle will be equal to this angle. Angle of incidence equals to angle of reflection. Well, okay, we don't want to study this. No need, forget it. Okay, just forget it what I said. But we should know the definition of reflection is nothing but the bounce back or rebounding of the light back into the same or in a different direction. Is like, okay, it can be in the same and different direction both. Okay, so like for example, this is my mirror. Mirror has one shiny surface, right? And the other surface is opaque. The light will come, fall on this mirror, and it will go in this direction. If it comes in this direction, just normally, just perpendicularly, it will go back into the same direction. Okay, so isn't it easy? Is it?
Yes, sir.
Yeah, it is very easy. Okay, let's move ahead. So like what we have discussed till now, we just started from luminous and non-luminous bodies, man-made and human-made. Okay, sorry, man-made and human-made both are same things, man-made or natural. Then we talked about non-luminous objects. Then we discussed about okay, we studied about light previously. Then we came to shadows. Then you both told me very good thing, which I was expecting that you would say wrong, but you said it rightly. I appreciate you both. You talked about, shadows are always black. But when you go to Google and just search for a word shadow, you will see many images coming with colorful shadows, which is wrong scientifically, right? So we should just, we should ignore those stuff that is technically wrong. Okay, then we talked about, then we came to topic did we do after shadows? We came to this one, never look at the sun. Okay, then we came to pinhole camera, right? Then we came to this, never look at the sun directly, then light travels in straight direction. Then we talked about the mirrors and reflection. And this brings us to the end of today's lecture and a small quiz for you children.